Hello, good morning. Hope you are doing well. Yeah, still in our series, we have talked about technical efficiency, Cobb-Douglas cross-section data, and transfer cross-section data. Now we want to talk about a technical efficiency measurement that using panel data. Okay. We are just talking about performance measurement, and we have many ways to measure performance, but in this case we'll be talking about technical efficiency, for example. And now let us have an overview of those terms of performance, technical efficiency, and so on. Okay. Here, for example, we are just measuring performance of decision-making units. It can be farm, household, commercial farm, banks, institution like university, whatever. But we have many ways, as I was saying, to measure performance. One way is efficiency. And now let's just see what's the difference between effectiveness as a performance measure and efficiency. Effectiveness is a ability to reach a target without just considering the inputs used. Okay, but when we are talking efficiency, we will achieve our target, but we are focused on how the resources are used. For example, here we have company A and B, and all of them reached output 10, the target, as you can see, but this one use only 2 units of input to reach this 10, and this one use 5. Can you see the difference now? Now we can see the company B is effective, but is not efficient. Since it reached the target, but the company A is efficient since it reached the target, but also minimize the input used. Okay, talking about productivity, you have to partial productivity when we are just using the ratio of output to a single input, like labor productivity, and the land productivity, like when we want to see the productivity of only one single input used. The total factor productivity is where we are aggregating everything, output and the input, and we see the ratio. Now to measure efficiency, rather technical efficiency, allocative efficiency, whatever, we have 3 approaches. We have non-parametric approach, non-parametric approach, semi-parametric approach. And when we want to use non-parametric approach, we have data development analysis. Parametric approach, we have stochastic frontier. Okay, let's talk a bit about them, those features of stochastic frontier analysis. Production output object subject to random shocks not under control of farmer manager. That show functional farm. Also only allow single or aggregated output, meaning that when you are measuring the efficiency of a farm and you have many outputs, you need to aggregate them to one output. You cannot consider output 1, output 2, output 3. Okay, these kind of things can be done with the non-parametric approach, which is data envelope analysis. This one also has its characteristic and allow for multiple outputs. Okay. And now, when we are talking about efficiency, we have technical efficiency, allocative efficiency, economic efficiency. So when we are taking a technical efficiency itself, is the use of best available technology. And now we have input-oriented technical efficiency and output-oriented technical efficiency. Okay, a farm is input-oriented technical efficiency when it can reduce. Okay, we have before a defined quantity of input we are using to get defined outputs, and now we can manage on inputs, reduce them, and holding constant the output we are producing. At that moment, we can say that the farm is input-oriented technical efficient, but also output-oriented technical efficient if we can. At some point, we had a quantity which is giving a defined quantity of output, that we can manage to add more our result, our output, without even reducing our input. At that moment, we can say that the farm is technical efficiency, output oriented. But allocative efficiency now also we have revenue based, cost based. There We are dealing with the price. The price, if we can manage the price of the output we are producing to maximize our revenue, or if we can manage the input or the price of the inputs we are just using also. That's cost-based allocative efficiency. And then we have cost efficiency, which is also called economic efficiency. The same thing around here, for example, since we are just talking about technical efficiency, to estimate technical efficiency, we need a Cobb-Douglas function or log, a translog function. But there we cannot choose what we want, but some tests like log likelihood ratio test, which help us to choose the best function we can use. Can you see how the Cobb-Douglas function looks like? Okay, then we need to linearize it and got something like this before. And now, when we want to do that, that means that we need to manipulate our data to linearize all those things before to proceed. Let's go and see what will happen there with our data. Okay, let's say that we have this kind of data. Since here we are considering this data as a panel data, and we see panel data is something which is collected with one company that's along many years, like here from 1997 up to 2018. What they see in here now, the length. Okay, you can see that it's just a farm. Okay, length and how to look at them. So we need to linearize it. Linearize it just to apply natural log on those values. And also here, okay, we have those kind of things. Since we are just dealing only with Cobb-Douglas, we need to linearize the output and those three inputs around here. Okay, at the end we will be having something like this. Okay, this ID is just saying that is what the same company where we are getting our data, and those what things we linearize. If you want also to see the effect of a variable, it can be the experience or climate change on what the technical efficiency, what we are just doing. We can just add this also variable. At the end, what we will be doing, we have all those things. We need now to copy them and go in our data. We can also export it in the normal way, but this one can allow us to go quickly. Let me clean what is inside there and put what we have. We copy that. Okay, we have our data around here. But at this moment, we can go and run. Yeah. Okay, let me say tell my machine or my software that I'm using panel data. Except yeah, and C ID. Yeah. Okay, I'm just telling data that this panel data I'm just using. It's what I did. Now at the end, now I can just use my those commands. Here is panel data I'm using. This will be SF panel. But if it was cross-sectional data, we will be using SF cross panel. And now I have choose the model EC again, or I can use the FF and output oriented and talk of the normal here around here. Okay. We do not add the condition model is not allowed. Okay, TFA. fixed effect. That's fixed, yeah, effect. And here also that. Okay, we have it. Even if it has not generated those errors, but it's okay. Up to now, we have those values around here, and also we are we want to see also the effect of climate change on our technical efficiency. It's not significant, but we are supposing if it was significant, this one, it was significant and negative, meaning that um, our climate change has positive effects on the technical efficiency of the company along the time, since from 1997 up to 2018. Okay, because what is estimated here is technical inefficiency. So this one is negative, we are saying that it has positive effect on technical efficiency. Okay, but here we need to generate even our technical efficiencies scores. It's those one even we want is for this reason we just run the model. Then those one are the one which are important for us here. Predict now. TFA, the model using here is TFA. We have technical efficiency, then we can go even and see how they look like. Those one are the scores. Okay, they are very small. Let's go back and summarize and see that. Okay, the mean is very okay. Let's say that the chemical efficiency score are between 0 and 1. When it is 1, that means that farm is totally efficient. When 0 is totally inefficient. But those score between more is closer to 0, we are seeing that the farm is inefficient. Huh? Okay, but when more close to 1, we can see that the farm is efficient. Now, this one is just a farm on from 1997 up to 18. Can you see that? Okay, all those scores are very small, tiny, exponent minus 17 and so on, closer to 1. Along the time, the farm was not technical efficient. It was technical inefficient. Since those ones are very closer to 0 and so on. Okay, I hope that this video will help you in further research. You can, if you need something, you can reach out as we are okay. We want to learn how to run even do software data, R, Python, SPSS, even how to digitalize your data, Kobo or Odeka, can just get in touch with us. Thank you for your time.